Greetings, class. This is Mrs. Lyons. This video will show you or help explain the periodic trend of atomic radius. Okay, so the first thing we need to know is that when we're talking about atomic radius, basically we're just talking about the size of the atom. Okay, and we're going to talk about two trends when we talk about any of the periodic table properties of atoms. We're going to talk about a trend going across a period. We're going to talk about a trend going down a group. So first we're going to talk about the period trend. So here I have period 2, the elements lithium, carbon, fluorine, and neon as we go from left to right across period 2. If you notice, as we go from left to right, the thing that the elements have in common, each of these elements has 2 energy levels, okay? The valence shell is the second energy level. So at a glance, they don't look like they are any different in their size, okay? The electrons in these atoms, since they're the valence electrons in these atoms, since they all are in the second energy level, they're the same distance from the nucleus, which means that we know that this nucleus has a positive charge. What it means is the electrons in the second energy level, whether there's 1 or 4 or 7 or 8, all of the electrons in that valence shell feel the pull of the nucleus equally, okay? So when we're talking about size, the thing that's going to matter is how positive the nucleus is, okay? So if we think about lithium, lithium has 3 protons. So essentially, the nucleus of lithium is positive 3, okay? If we look at carbon, the nucleus of carbon has how many? It has 4 protons, okay? So that would tell us, and I'm not going to leave that in there because it will mess things up, but carbon would have 4 protons in its nucleus. Fluorine would have 7 protons. Neon would have 8 protons. Okay, so as we move from left to right, the atoms with the greater number of protons and therefore the greater positive charge, what's going to happen is the electrons, and it says this down here, the more positive the nucleus, the stronger the pull. Okay, and what that means, and I'm going to get my favorite little tool out, my scribble. What that means is this nucleus is going to pull these electrons towards it, okay? It's going to grab hold of those electrons and it's going to pull them in because it's got more positive charge. It's going to grab hold of them and pull them close, okay? And the result of that is going to be a smaller atomic radius, a smaller atom, okay? So the key thing that we want to think about is that as we're talking about atomic radius decreases, okay? This is the big point that we want to know. Atomic radius decreases as we move from left to right across a period. I was trying to highlight that. There we go. All right, so that's the important thing. The next thing we need to look at is what happens as we move from top to bottom down a group. Okay, so I have just 2 elements in this group. I have lithium and I have sodium. And hopefully the thing that jumps out at you is that lithium has 2 energy levels. The thing that these atoms have in common, they both have 1 valence electron. The thing that's different is lithium has 2 energy levels, sodium has 3 energy levels. If we continued down the group, each element as we go down would have 1 additional energy level. So what that means is, and we can see that, it's visibly easy to see as we go down, that added energy level makes the atom larger, Okay. The other thing, if we apply this, not if we apply the positive nucleus, you might think, well, yeah, but the nucleus is more positive. Why doesn't that make a difference? One thing that we need to think about when we're talking about that is this idea of shielding. And we talked about this in class. And what shielding means is that, let me get my little scribble tool again. What shielding is it means that these electrons in the middle keep the outermost electrons from feeling the positive pull of the nucleus. So the farther away the valence electrons are, the less they're going to feel the positive nucleus. So that means as we go down a group, that pull in is going to get less and less. Okay. And that means that the atoms are going to get larger. All right. So that's atomic radius. I hope that helps a little bit. Oh, let's just be consistent here and underline. So as we go from the top of a group to the bottom, I'm having trouble with our atomic radius is going to increase. All right, so that we have the two properties, the two trends for atomic radius or size. It decreases from left to right, increases from top to bottom. Have a good day. I hope this helps, and I will see you in class.